So my name is Elena. I am a developer advocate at Ivan. And today, together, we will be diving into the data with the help of OpenSearch and its Node.js client. I bet that every one of us in this room deal with data in one or other way. And for the success of the applications we build, we need to deal with it quickly and efficiently with the tools we can trust. That's why today I suggest we look at OpenSearch, a high-quality and secure search engine and analytics suite. Could you raise your hand if you used or heard about OpenSearch before? No, that's great, then you can learn something new. Could you raise your hand if you use Elasticsearch? We have a couple of hands. So OpenSearch is a fork from Elasticsearch, and the separation happened a year ago when Elastic changed the license. So today is a great opportunity to learn how you can apply the power of OpenSearch to your JavaScript projects or any other projects in other languages. So we will see how you can search for data, how you can aggregate the data, and how you can visualize the data. But before we dive into the code, let's quickly align on the terminology that we will be using. So OpenSearch is both a data store and the search engine. And the power and intelligence of OpenSearch comes from how it analyzes data way before we start searching. The schema or the structure of the data is called mapping. And the process of processing the data is called indexing. During the indexing, OpenSearch will create a set of documents analyzing your data and giving it bigger meaning than just strings of characters. Those documents are then stored on one or more shards, and dividing data across shards allows us to do the horizontal scaling. Next to the shards, we keep replicas for redundancy and resilience, and also to make the performance of the cluster to be faster. Shards and their replicas are balanced across nodes. And if any of our nodes or if any of our servers crash, then we will be still fine. We still have a complete set of data, and our customers will not notice any negative effects. A set of nodes is called a cluster. And to communicate with a cluster, we can use JSON-based REST API over HTTP. So you can use such tools as curl or your favorite programming language to communicate with a cluster. But that would mean that you need to parse the response and also create stable requests, so it's easier to rely on one of the available clients. And today we will be looking into using JavaScript client. If JavaScript is not your cup of tea, no worries. There are other languages available for the clients. And this is a quick introduction into OpenSearch. And now that you're proficient with the theoretical part, let's move on to the practical one. And actually, if you would like to follow and do the same exercises with me, feel free to get the GitHub repository. There are all examples which I will be showing, and actually more examples there. So you can find in the GitHub repository all the JavaScript files which we will need, which we will be using to run. And also you can find the README instructions on how to set up a connection to your OpenSearch cluster, because of course we are doing OpenSearch examples, so you need to have an OpenSearch cluster for that. OpenSearch is an open source product, as I mentioned, so you can use its source code and follow the instructions from the opensearch.org to set up the cluster locally on your machine or on the cloud, or you can use one of the available managed options, and there are different alternatives available on the internet. Personally, I will be using Ivan for OpenSearch not only because I work for Ivan, but also because I think it's a very friendly version to work with the cluster. And by the way, you can use it as well. There is a free trial, which is totally sufficient for all the examples I will be showing, so you can keep this option in mind. And here I already have a service URI, so my service is up and running. And I will be using a connection string to connect to the cluster. My connection string, by the way, already involves the username and password, so I don't need really to have any other properties. And the last thing which we will need is, of course, the data itself. And I decided that nothing unites us as good as food. So today, you and me, we are becoming the professional critics, and we will be using a dataset from Kaggle with 20K recipes, with nutrition data and ratings. So with the help of OpenSearch, we will be able to see what awesome or awful things, depending on your perspectives, people do with food. So you will need to download this dataset and put into the project which you hopefully clone or will clone if you want to follow it later. So I have the JSON file with all the recipes over here. And since I'm already on the project site, let me show you around. It is a JavaScript project, and it's quite minimalistic one. So in the package JSON, we can see that we have a library for OpenSearch client. I'm also using here a .env library so that I have a proper place where I can store the connection string to my cluster. You can put your connection string in .env.example, so remove the .example part, you don't need that. And in the .env file, add your service URI, or depending on how you connect to the cluster, you might want to add some additional parameters. And once we have service URI, we can create our client. All the stuff related to the client configuration I put into the config.js. So we create our client, we rely on OpenSearch client over here, and we provide the information about service URI. Maybe you will need to add some additional authentication stuff. And this is how our client, we will use it across other files. In this place, I also indicate the name for the index, just that we have it consistently used across all other modules. And I point to the recipes, to the data which we will be injecting into the cluster to our set of recipes. Talking about the data, let's bring it into the cluster. Everything related to indexing or indices, I put into the index.js. And here at the top, we have inject data method. So let me run it, because I'm not sure how much I can rely on the internet here, so not sure how long it will take. And meanwhile, I can show you what is happening here. So you can ingest data line by line. For example, you have some server which sends log information into your OpenSearch cluster. And then you probably want to bring the data line by line. However, it is possible also that you have a bulk of data and you want to inject it at the same time. And this is our case, we have tons of recipes. So that's why we are using a bulk endpoint. And bulk endpoint expects a flat list of items where the action followed by an optional document. It's like followed one after another. And here we are going through all the recipes which we have and saying that we would like to index each of the recipes and send it into the cluster. And to make it easier for me and for you to run the code through the command line, I'm relying on run func utility over here. So I know some of you JavaScript developers, you might say we can also use the NodeJS built-in functionality, and that's true. So it's up to you. So our data seems to be successfully injected. So we tested also the internet over here. It took us 10 seconds and we didn't have any errors. So you might have noticed that when we injected the data in this small method, we don't really provide any structure for the data. Actually, we let OpenSearch to decide on the structure for ourselves and look at the properties which we have and the most fitting type based on the data we provided. And this is called dynamic mapping, and this is quite convenient for the case where we're exploring the data. So, of course, you can specifically set the mapping, but I think for the cases like ours, it's very convenient. Of course, we are curious what properties we have in the dataset. So we send some JSON file. Let's see what we have in those recipes. So I have a method, getMapping. Here, indeed, we are relying on the help from the client. And in the namespace indices, we request the mapping for our index. So I'll clean this, and I'll request the properties from the mapping. And we see that OpenSearch decided that every recipe has calories, categories, different properties such as ingredients, rating, title. Also, it decided on the type of the properties. So we have some numeric values for the protein or sodium or rating. We have some text values for directions and also a date for when the recipe was added or created in this dataset. So keeping this in mind, we can now send some requests to the cluster and search for something. So let's do exactly that. Let's search for something simple. So the examples we search you can find in search.js. And here at the top I have a match search. Let's start with it. And I decided that, searching for pizza with pineapples is too boring. And since I'm actually coming from Berlin, let's search for soups with beer and garlic. Interestingly enough, we got some delicious kind of weird propositions. So if we check the match method, you can see that we here used the search endpoint, and we send the body of the search request. And the body is a kind of a JSON object with some hierarchy, and it can get a bit confusing at first. However, no worries. What you need is just a simple lesson on anatomy. And sadly, not the corgi's anatomy. I would love to do that, but one of the requests. So we will start with the search query. And the search endpoint accepts a long list of potential parameters. But for a simple request, we need just two. The first one is the index where exactly we are searching. So we are searching in the recipes index. And the second object is the body of the request. It is a JSON object in domain-specific language, where the parent object is a query, and then we need to define which type of the query. And in our case, we were using match. There are other queries we will see in a couple of minutes. Then we defined in which field we are searching, and we used title, and finally the keywords themselves. So OpenSearch, based on our request, tried to retrieve us data sorted by relevance so that we get the most relevant results first. And you can see that the first item includes all the keywords, soups, beer, and garlic. And the rest have less and less. Such words as with or and, they actually not so important for OpenSearch. It knows that it can ignore those words. They are not the key ones for us. And interestingly enough, beer, for some reason, is one of the most important words in this search. So, and this is the match request. You can see it's very free-flowing. OpenSearch does a lot of judgment for itself to how and what to return. Sometimes we have the situation where we want to control and make it more strict how the words should be following for our requests. And maybe what is the distance between the words? Are they in the same context or are they spread across the text? And for this, there is a different type of request, which is called match phrase. Over here, I am looking for milk chocolate cake. And if we send such a request to the OpenSearch cluster, it will strictly look for all instances where we have those three words in this order followed one after another. We might want to relax this condition a bit and add a bit more space in between. We might want to have these words across one paragraph or maybe like another words, and this can be done with the property slope. So slope defines that we can have a distance over here, it's a 10, of 10 other different words, how our keywords are spread. And we can see this in action. There is an example for the phrase method, for the match phrase, where we specify field, query, and the slope. So we can search for our milk chocolate cake and we can start without any slope. So we found only one example where those three words are strictly following one after another. Let's add a slope of 5. So we say the distance can be maximum 5 other words. And it gave us back some other suggestions. So now we have also milk chocolate mousse cake or chocolate cake with milk chocolate peanut butter frosting. So plenty of delicious results, which also make me quite hungry. So this is a match phrase example. For searching for the specific terms or specific dates, maybe numbers, we can rely on the term query. For example, we would like to find all recipes where the sodium value is equal to 0, or all recipes with a sodium value from 0 to 100. When we use term queries, relevance doesn't play any role because technically all those results are equally relevant. It's more like filtering the data based on the terms. And at this point, you might be wondering how we can combine several conditions in one query. And there are several ways we can do it. The first one is to use a query string. So over here, we can use a single string where we will define our condition and we will mark them by plus, minus, brackets, and other symbols. In particular, this one, I am looking for pizzas. Like the pizza is a must for my query. And I heard that pineapple is not really good with pizza, so I exclude. Pineapple is a must not. But of course, I like something sweet on my pizza, so I would like to have mangoes or strawberries. If there is a mango or strawberry, those results should get upper in the relevance. So this is how you can combine, and this is a very powerful way of writing a request, especially if you want to have a compressed version, I don't know, like use again curl or something. But the problem is that with the time, this line will get very long and then difficult to maintain and support. So the other option, which we have, might be a bit better. You can use the Boolean type of queries. In the Boolean queries, we define all those conditions for must not, what should be there, and how to filter stuff with the help of separate JSON objects. And all these examples you can again find in the same file with search.js, and you can run them, you can break them. That's the best way to learn if you want to experiment with OpenSearch. And by now, I hope I convinced you that OpenSearch is great at searching for data. But interestingly enough, many of companies will use OpenSearch not for searching, but for aggregations. Aggregations, unlike searching, will give us some information, some insights about the data, some statistics, some metrics, some like overall where our data is moving, any anomalies or anything else we should pay attention to. And there are several types of aggregation available in OpenSearch, such as metrics, bucket, and pipeline. So let's do them one by one. In the metrics aggregation, we calculate a single value, so we can find average rating across our recipes, for example, or the maximum value for calories in our dataset in our recipes. Or maybe we want to sum up some particular fields and find something. You can combine search requests with aggregation requests. And in fact, they are part of the same endpoint. For aggregations, we also depend on the search endpoint. And we can combine query with a new object, which is called aggregations or aggs, where we will name our aggregation. And for metric type, we also specify the metric type. So, for example, we can search for average in the rating field. And we can do that by going to aggregate.js, and at the top there is the metric example where you provide the type of the metric and the field. So let me search for average rating. It is 3.7. I don't know, looks fine to me if it's from 1 till 5. Another example of aggregations is a bucket aggregation. It's when we want to create a set of buckets where we will separate and split our documents. For example, again, taking into account the rating value, we can have a bucket where we will be putting all the recipes with the rating equal to 1, then rating equal to 2, and so on. And then we can work with those buckets separately and do some other operations. So it's also called a histogram, and this is example when we use a numeric property. So here, rating is a numeric for us, but it can be also done with some stuff like dates. So you remember that we had a date property in our dataset. So we can actually sneak and see how many recipes were added every year. So how they are spread over the years. Or if we need, we can also say, oh, I want to have 10 buckets. And OpenSearch, please split our data across all 10 buckets, kind of counting all the recipes correctly. So we can, for example, run the one for the date histogram over here. So let's use a date as a field and a year as an interval. And if we do that, we receive a set of buckets and information about the bucket. And we can see that the first ever added recipe into this dataset is marked by the year 1996. And there was a small number of recipes added up until 2004, where we have 11,000 items. And this is a bucket aggregation. Another interesting type of aggregation, and probably the most complex, is the pipeline aggregation, where we aggregate data, and then we do the second aggregation on top of that aggregation, and then we retrieve the result. With the help of pipeline aggregations, we can do such calculations as moving averages. And there are certain functions already available in OpenSearch, which you can use for that. So when we use a pipeline aggregation, we start again with some kind of aggregation. Here I'm calculating a moving average over 3 years for the number of recipes added into our dataset. And I start again by the date histogram, based on the date field for a year. Then I create a second aggregation on top of it, where I count all the recipes for every bucket. And finally, I add a moving average, which glues our previous aggregation, and we can specify here a function which we want to run on that data. And here I'm using the built-in function for calculating unweighted average for values. And this is a place also where I specify the size of the window, how we move like steps, and other properties. So if we run this, it will return us quite similar result to the bucket, with the difference is that every time we have a moving average value which calculates the amount of recipes added on average for the last 3 years. And this is pipeline aggregations. And I think that by now you're quite bored with the terminal and IDE. So let's move to something a bit more colorful. Let's look at the visualizations which we can do with OpenSearch. And I will use for this OpenSearch Dashboards. Whether you are using OpenSearch cluster set up locally or in the cloud or managed service, any of those, OpenSearch Dashboard always accompanies OpenSearch. They go together. And for those of you who are familiar with Elasticsearch, OpenSearch Dashboard is equivalent to Kibana. So over here, we can go and open our dashboards. And yeah, let's start with visualizations. There are plenty of cool stuff here, but I think we are not having so much time. So let's actually create, remember we were talking about the histogram, how to divide our data into buckets based on the value of the rating of the recipe. So I will use a horizontal bar over here from the recipes, and then I will say, oh, OpenSearch, please create us buckets on x-axis and use histogram as aggregation. And for the field, we want to rely on the rating. And we don't want to use auto interval, we will use interval of 1. And I will update this. And this, you can imagine, these are buckets. So all of these buckets with amount of items for every value of the rating. So the biggest bucket we have for the rating with value 4. There is a small portions of recipes probably people hated with rating number 1. Also, there are some recipes where obviously we don't have any rating at all, rating 0. So this is how we can visualize the bucket aggregation. Another aggregation we can add is the tag cloud, for example, where we can explore what are the categories. So we had a categories field, and we can add the aggregation by terms here, and we can rely on the categories over here and bring the most popular 15 categories into the cloud. And this is the list of the most popular categories. Bon Appetit sadly doesn't tell us much, but we see here that we have some vegetarian dishes, some dairy-free, some desserts, so plenty of stuff. We can also see, by the way, what are the least popular categories, or where we have less of the items, and we can just change the order and find the 15 least popular categories. And this is, they are. I'm really curious why burrito is so not popular. I think it's very under-evaluated. So apart from this, in the dashboards, we can use different plugins, for example, to set up alerting, reporting, observability. So there are plenty of stuff you can add on top of the OpenSearch. And this is also a great tool to discover your data. So sometimes, of course, you know your data well, but sometimes you start with a data set and you're like, oh, what do I have there? And it helps when you have a visual tool that you can use. So here we can actually look at our items individually. We can filter and search for items based like with the help of the UI elements. You can also combine the search conditions in the search field. You can also create tables over here and so on. So it's pretty nice visual effect. And what is also interesting is that if you are a developer and you're like, oh, how do I structure a good request to send to the OpenSearch cluster on my own through the programming language, you can then go and see how the OpenSearch dashboard does it and find the query object over here, which will show the example what you search with a visual interface. And on top of it, you can use a dev tools, which is located over here, where you can run the queries to experiment and kind of to tailor and see if this is how it works for you, for the programming language. So it's like to have a visual interface, especially if you are not a developer and you still want to work with data. So for example, here I can search the same soups with beer and garlic, and we can find the full response from OpenSearch cluster. So to leave some time for questions, I think I can slowly finish. So again, this is the QR code to the repository where you can find all those examples and others which we didn't cover today. And finally, if you are thinking of using OpenSearch and you are looking if it's really indeed the solution which you need, check out ivan.io. For transparency, this is the company where I work, and we have a managed version for OpenSearch and a free trial you can use to evaluate it. So thank you so much for being at the session, and I'm all ears to your questions.